In this class, we read some basic trigonometric formulas. Let's start from the beginning. Let us consider a right angle triangle. Now, opposite side of the angle theta is called as perpendicular. Opposite side of the right angle is called as hypotenuse, denoted by h, and the adjacent side of the angle theta is base, denoted by b. Now the relation between PBH is a square equal to p square plus b square. There are 6 trigonometric functions which are expressed as the ratio of the sides of a right angle triangle in this form: sin theta, p by h, cos theta, b by h, tan theta, p by b, cot theta, b by b, sec theta, h by b, and cosec theta, h by b. So from these ratios, we can say that cosec theta equal to 1 by sin theta, sec theta equal to 1 by cos theta, cot theta equal to 1 by tan theta. So cosec theta and sin theta are reciprocal to each other, sec theta and cos theta are also reciprocal to each other. Similarly, tan theta and cot theta are also reciprocal to each other. And tan theta, we define tan theta equal to sin theta by cos theta, cot theta equal to cos theta by sin theta. Similarly, you have to remember another. Similarly, sin theta equal to tan theta by sec theta, and cos theta equal to cot theta by cosec theta. We have to remember these two also. Now, there are trigonometric identities. Sin square theta plus cos square theta equal to 1. So you can write sin theta equal to plus or minus square root of 1 minus cos square theta, and cos theta equal to plus or minus square root of 1 minus sin square theta. Under trigonometric identity, sec square theta minus tan square theta equal to 1. From this, sec theta equal to plus or minus square root of 1 plus tan square theta, and tan theta equal to plus or minus square root of sec square theta minus 1. Or the trigonometric identity cosec square theta minus cot square theta equal to 1. From these, cosec theta equal to plus or minus square root of 1 plus cot square theta, and cot theta equal to plus or minus square root of cosec square theta minus 1. So to remember this, sec theta equal to plus or minus square root of 1 plus tan square theta, and cosec theta equal to plus or minus square root of 1 plus cot square theta. Similarly, tan theta plus or minus square root of sec square theta minus 1, and cot theta plus or minus cosec square theta minus 1. Most important thing. So, trigonometric substitution. If the minus square root of 1 minus x square. The trigonometric substitution for x is sin theta or cos theta. If you put x equal to sin theta, then it is cos theta. If it is cos theta, then it is sin theta. So substitution for x is here cos theta, sin theta or cos theta. We may use sin 2 theta, cos 2 theta or any other thing. If it is 1 plus x square, then trigonometric substitution of for square root of 1 plus x square is these two identities and this, that is it is tan theta cot theta. Similarly, trigonometric substitution for square root of x square minus 1 is obviously sec theta and cosec theta. If it is a square minus x square, same as on this, we use a sin theta or a cos theta. Similarly, trigonometric substitution for a square plus square root of this, it is a tan theta or a cot theta. Trigonometric substitution for x square minus a square, square root of this is a sec theta or a cosec theta. Most important thing, we have to remember these conditions. Now, trigonometric functions for compound angles. Trigonometric functions of compound angles. Sin a plus b, it is sin a into cos b plus cos a into sin b. Similarly, sin a minus b, sin a into cos b minus cos a into sin b. Similarly, cos a minus b, cos a into cos b plus sin a into sin b, cos a plus b, cos a into cos b minus sin a into sin b, tan a plus b, tan a plus tan b by 1 minus tan a into tan b. Similarly, tan a minus b is tan a minus tan b by 1 plus tan a into tan b. Similarly, cot a plus b equal to cot a into cot b minus 1 divided by cot b plus cot a. Similarly, cot a minus b equal to cot a into cot b plus 1 by cot b minus cot a. Now, by using this formula, addition to multiplication for sin c plus sin d equal to 2 sin c plus d by 2 cos c minus d by 2. Similarly, sin c minus sin d 2 cos c plus d by 2 into sin c minus d by 2. Very simple, we have to interchange sin and cos. For sin c plus sin d, it is 2 sin c plus d by 2 into cos c minus d by 2. Sin c minus sin d, we have to replace cos in place of sin and sin in place of cos. Similarly, cos c plus cos d 2 cos c plus d by 2 into cos c minus d by 2. Cos c minus cos d minus 2 sin c plus d by 2 into sin c minus d by 2, or we can write it as 2 sin c plus d by 2 into sin d minus c by 2. Then multiplication to addition for multiplication to addition for 2 sin a into cos b equal to sin a plus b plus sin a minus b. Similarly, 2 cos a into sin b equal to sin a plus b minus sin a minus b. 2 cos a into cos b equal to cos a minus b plus cos a plus b. Similarly, 2 sin a into sin b cos a minus b minus cos a plus b. Very easy to remember this condition, because if there is 2 sin a into cos b, the first thing it is the first term of which compound angle? That is sin a into cos b is in the compound angle sin a plus b. So it is the first term. We know that formula for sin a plus b is sin a into cos b plus cos a into sin b. And sin a minus b is this minus this. By adding these two, by cancelling these two, it is 2 sin a into cos b. Similarly, 2 cos a into sin b. It is the second term for the compound angle sin a plus b. So by subtracting, we get sin a cos b minus sin a cos b cancelled. That is plus 2 cos a sin b. If 2 cos a into cos b is there, then this cannot be written in the form of sin, because 2 cos a cos b, cos a into cos b is the first term of cos a minus b or cos a plus b. So to find 2 cos a cos b in addition form, if you add these two terms, then the second term cancelled, so you get 2 cos a cos b. Similarly, to find 2 sin a sin b, it is the second term for the compound angle cos a minus b or cos a plus b. So by subtracting these two, we get cos a minus b minus cos a plus b. We can remember in this way also. Now, trigonometric functions of multiple and submultiple angles. Formula for sin 2a. We know that the proof for sin 2a, to find sin 2a, we have to write sin a plus a. In place of b, we have to put a, that is sin a into cos a plus cos a into sin a, same term. So by adding these two, we get 2 sin a into cos a. So formula for sin 2a is 2 sin into cos a. We can also say by using this formula directly, We know the formula for sin A plus B is sin into cos B plus cos A into sin B. So in place of B you have to put A, that is sin into cos A plus cos A into sin A, that is 2 sin into cos A. In form of tan, it is 2 tan A by 1 plus tan square A. Similarly, formula for cos 2A. We can also prove it. The second one, we can prove the second one by using sin 2A. We know formula for sin 2A is 2 sin into cos A. Simply by putting A in place of B. Now, to reduce in tan form, we have to divide a cos A, that is sin A by cos A into cos square A. Now I have to multiply again a cos A to balance this term. Now we can write 2 tan A. Again cos square A is 1 by sec square A. So we can write 2 tan A by 1 plus tan square A. So formula for sin 2A is 2 sin into cos A in form of tan 2 tan A by 1 plus tan square A. We also write sin 2A in form of sin only. To write in form of sin, we can write 2 sin A into square root of 1 minus sin square A if A is an acute angle. Similarly, formula for cos 2A. Similarly, you have to put A in place of B, that is cos A into cos A, which is equal to cos square A minus sin A into sin A, that is sin square A. Or if we write in place only form of the sin, we can write 1 minus sin square A minus sin square A, that is 1 minus 2 sin square A. In form of cos only, we can write it as, we write 1 minus cos square A, that is minus 1 plus cos square A, that is 2 cos square A minus 1. Similarly, in form of tan, we can write 1 minus tan square A by 1 plus tan square A, the formula for cos 2A. Similarly, to find tan 2A, formula for tan 2A, we have to put A in place of B, that is tan A plus tan A to 2 tan A divided by 1 minus tan into tan A, that is 1 minus tan square A. Similarly, cot 2A, that is you have to put A in place of B, that is cot A into cot A minus 1. Cot 2A equal to cot square A minus 1 by 2 cot A. We have to remember this formula, which are most important. Another trigonometric functions of compound angle, sin A plus B plus C which is equal to cos A into cos B into cos C equal into tan A plus tan B plus tan C minus tan A into tan B into tan C. Similarly, formula for cos A plus B plus C, which is equal to cos A into cos B into cos C equal into 1 minus tan A into tan B minus tan B into tan C minus tan C into tan A. Similarly, tan A plus B plus C equal to tan A plus tan B plus tan C minus tan A into tan B into tan C divided by 1 minus tan A into tan B minus tan B into tan C minus tan C into tan A. So by using this formula we can write sin 3 equal to 3 sin A minus 4 sin cube A. Similarly, cos 3A, 4 cos cube A minus 3 cos A. That is very easy if you remember in this way. That is sin 3A, 3 sin A minus 4 sin cube A, and cos 3A, 4 cos cube A minus 3 cos A. That is if you remember 34 for sin 3 and 43 for cos 3A. You can remember easily. Similarly, tan 3A. That is you have to put A in place of B and C. That is tan of A plus A plus A, which you can write tan A plus tan A plus tan A. That is 3 tan A minus tan A into tan A into tan A. That is tan cube A divided by 1 minus tan into tan A, tan square A, tan A into tan A, tan square A, tan A into tan A, tan square A. That is 1 minus 3 tan square A. Another formula, we can write sin A tan A as 1 minus cos 2A by sin 2A, and cot A 1 plus cos 2A by sin 2A. We know that 1 minus cos 2A is 2 sin square A, because the formula for cos 2A are cos square A minus sin square A, 1 minus 2 sin square A, 2 cos square A minus 1, and 1 minus tan square A by 1 plus tan square A. So 1 minus cos 2A is 2 sin square A by 2 sin A into cos A. That is here, it is 2 sin square A divided by 2 sin A into cos A. By cancelling this, sin A by cos A tan A, so you can write in this way. Similarly, it is 2 cos square A by 2 sin A into cos A, that is cos A by sin A, cot A. Similarly, we also write tan square A tan A equal to square root of 1 minus cos 2A by 1 plus cos 2A. Another important formula. So, trigonometric substitution for 1 minus x, square root of 1 minus x by 1 plus x is cos 2. Cos 2 theta or cos theta. That is 1 minus cos 2 theta by 1 plus cos 2 theta, which is tan theta. The trigonometric substitution for x. Now, For theta acute, suppose theta 0 less than theta less than 90 degree. If sin theta equal to x and theta is an acute angle, then find other 5 trigonometric functions. Sin theta equal to x. If sin theta is given, immediately we can find cos theta. Square root of 1 minus sin square theta, that is 1 minus x square. Again, tan theta equal to sin theta by cos theta, which you can write x by square root of this. From this we can find cot theta, which is 1 by tan theta, sec theta 1 by cos theta, and cosec theta 1 by x. As theta is acute angle, so we use plus square root of 1 minus x square. Similarly, if cos theta equal to x, then find other trigonometric functions. If cos theta equal to x, then immediately we can find sin theta. As if cos theta equal to x, implies sin theta equal to square root of 1 minus x square root over. Then we can find tan theta sin theta by cos theta, cot theta cos theta by sin theta, 1 by tan theta, or others. So in the same question, if tan theta equal to x, then find other trigonometric functions. If tan theta is x, then immediately we can find sec theta, which is square root of 1 plus x square. So cot theta, if tan theta equal to x, then immediately we can find sec theta. As in trigonometric identity, sec theta and tan theta are related. We need other 5. If tan theta is given, then we can find immediately cot theta. If sec theta is given, we can immediately find cos theta. We need sin theta and cosec theta. We know that sin theta equal to tan theta by sec theta. Most important thing, you have to remember this condition. X by square root of 1 plus x square. If tan theta is given, then we can find cot theta, sec theta, we can find cos theta. If sin theta is, we can find sin theta, then we can find cosec theta. Similarly, if cot theta is given, we find other 5. Immediately we find cosec theta. We have to remember this condition, the square root of 1 plus x square. If cot theta is given, we can find sin theta, cot tan theta. If cosec theta is given, we can find sin theta. We need cos theta and sec theta. We know that cos theta equal to cot theta by cosec theta. So x by square root of 1 plus x square. Similarly, if sec theta is given, we have to find other 5. So if sec theta is given, immediately we can find tan theta, because sec and tan theta are related in trigonometric identity. That is tan theta equal to sec square theta minus 1 square root of this, that is square root of x square minus 1. If sec theta is given, we can find cos theta. If tan theta is given, we can find cot theta. We need sin theta and cosec theta. We know that sin theta equal to tan theta by sec theta, so we can immediately find this. If cosec theta is given, immediately we can find cot theta. As cosec theta and cot theta are related, so cot theta equal to square root of x square minus 1 as cosec theta equal to x. So if cosec theta is given, we can find sin theta. If cot theta is given, we can find tan theta. We need cos theta and sec theta. We know that cos theta equal to cot theta by cosec theta, that is square root of x square minus 1 by x. So most important thing, if sin theta is given, we can immediately find cos theta. If cos theta is given, we can immediately find sin theta, then all others. If tan theta is given, we can find immediately sec theta. If cot theta is given, we can find immediately cosec theta. And if sec theta is given, you can find immediately tan theta, and if cosec theta is given, you can find immediately cot theta. Another method is there. If sin theta equal to x, then find other trigonometric functions. Let it be theta. Sin theta equal to x. We know that sin theta equal to p by h. That is here p equal to x and h equal to 1. Obviously p equal to square root of s square minus p square, that is 1 minus x square. From this you can find cos theta, tan theta, sec theta, cosec theta. Similarly, by using this formula you can also find if cos theta equal to x, then find all other trigonometric functions. For example, take another example. If tan theta equal to x, then find all other 5 trigonometric functions. We know that tan theta equal to p by b. Here p equal to x, b equal to 1 implies h equal to p square plus b square, that is square root of 1 plus x square. Now you can find sin, cos, sec, cot, sec, cosec using this formula. So you have to remember these conditions. Now trigonometric functions of negative angle. Sin of minus theta equal to minus sin theta, cos of minus theta plus cos theta. If you remember these two, we can find other 4, because tan of minus theta is sin of minus theta by cos of minus theta, which is minus tan theta. Cot of minus theta is minus cot theta. Similarly, sec of minus theta plus sec theta, cosec of minus theta minus cosec theta. You have to remember these conditions. Now you have to remember some trigonometric values, like if sec theta plus tan theta equal to 2, then find all trigonometric functions. If sec theta plus tan theta equal to 2, then find all trigonometric functions. Find the value of all trigonometric functions. Find the value of all trigonometric functions. Solution. If sec theta plus tan theta equal to 2 implies sec theta minus tan theta equal to 1 by 2. We know that sec square theta minus tan square theta equal to 1. We know that sec square theta minus tan square theta equal to 1. From the trigonometric identity, we can factorize it as sec theta plus tan theta whole into sec theta minus tan theta equal to 1. So obviously, sec theta plus tan theta equal to 1 by sec theta minus tan theta, and sec theta minus tan theta equal to 1 by sec theta plus tan theta. You have to remember this condition. If sec theta plus tan theta is given, then immediately we can find sec theta minus tan theta, that is 1 by sec theta plus tan theta, that is 1 by 2. So by adding these two, let it be 1 and it be 2. By adding 1 and 2, equation 1 plus equation 2 implies 2 sec theta equal to 2 plus 1 by 2, that is 5 by 2. So sec theta equal to 5 by 4. So we can find tan theta, again sin theta and cosec theta. If sec theta is given, then we can find tan theta, again sin theta equal to tan theta by sin theta. Then others are the reciprocal of the others. Similarly, if the same question is cosec square minus, in the form of cosec square minus cot square theta, we can write it as cosec theta plus cot theta whole into cosec theta minus cot theta equal to 1. Similarly, if cosec theta minus cot theta is given or cosec theta plus cot theta is given, then to solve it, we have to use this. We have to solve in this way. And we have to remember some trigonometric values like sine 15 degree root 3 minus 1 by 2 root 2. We can prove it by write sine 45 minus 30 degree. You have to remember this values. Similarly, cos 15 degree equal to root 3 plus 1 by 2 root 2. And tan 15 degree is equal to sine 15 by cos 15 degree, that is root 3 minus 1 by root 3 plus 1, which can we write 2 minus root 3 by rationalize these two terms, root 3 minus 1 by root 3 plus 1, we get 2 minus root 3. Similarly, cot 15 degree, which is equal to 1 by tan 15 degree, that is 1 by 2 minus root 3, which you can write 2 plus root 3. If sine 15 degree is given, we can immediately find this is same as cos 75 degree, because we can write 15 degree as 90 minus 75 degree, that is sine 90 minus 75, that is cos 75 degree. Similarly, it is same as sine